So we're going to talk about rounding. I know we talked about this last week, but I'll just briefly talk about it one more time. Um, you guys know how to do rounding from what grade was it? Like first grade or so, right? Okay. So rounding should be fairly easy. We're just going to round based on what the next place value is. So if the digit to the immediate right of the last sig fig is less than 5, don't change it and leave that. So for instance, if we were rounding to the hundredths place here, 2.53, I'd look at the 3 as my last sig fig, and I go, okay, the 2 tells me to leave it alone, which is why we get that answer of 2.53. Okay. If, on the other hand, that other digit is bigger than 5, if it's 5 or bigger, like here, the 6 is telling us that we should be rounding up. So we change it from 2.53 to 2.54. So here's how we deal with rounding. All right. Excuse me. We've got some fictional numbers here, guys. Pretend that all of them have units. So all of them have a certain number of sig figs. Okay. So the number of sig figs in a result is going to be determined by the smallest number of sig figs in those values. And notice that this is for, I gotta get my pen again. Here we go. This is for multiplication and division. Okay, so in multiplication and division, when we're going to get our final results, we're going to be looking at how many sig figs are in each of those numbers. So for instance, when I look at the number 13.77, I'm seeing a total of 4 sig figs. You guys agree with me? When I look at the number 4.0, I'm seeing 2 sig figs. Are we on the same page? Yeah? Okay, so when I plug into my calculator 13.77 multiplied by 4, my calculator says 55.08. I'm going to round my answer to have the same number of sig figs as the smallest number of sig figs, which happens to be 2 here, right? So I'm not going to write 55.08. Whoops. I'm not going to write 55.08 as the calculator says that I should. I'm going to round it. The 0 tells me to leave the 5 alone, so my answer here is going to be 55. Try out another one together. 3.800, how many sig figs? Okay, I'm hearing 4. 0.156, how many sig figs? 3. Okay. 3.8 times 0.156. Calculator spits out 0.5928. Okay. How many sig figs do I want in my answer? Smallest number is 3. So I'm going to take the 5, the 9, and the 2. Those are my first 3 sig figs in that number. And I'll use the 4th one to determine how to round that to. So I will have an answer of 0.593 since the 8 rounds the 2 up. Sylvia? Did I do that wrong? 13.77 divided by, what am I dividing by, 4? Oh, shoot. All right. Thank you, Sylvia. All right. So the answer I should have gotten in the first one was the calculator spits out 3.4425. Since we only want 2 sig figs, I'd pick out the 3 and the 4. The next 4 tells me to leave that 4 alone. So it looks like we're getting 3.4 as a final answer, right? Okay. So when I do the math, calculator spits out 0.12032, right? It looks like to me Looks to me like I can't find the mouse again. There we go. There's 2 sig figs in 4.7. There's 3 in 25.6. And how many in 1,000 the way it's written? 5 the way it's written, right? Okay, so I want the fewest number, which happens to be 2. So I'm going to take my first 2 digits there, the 0.1 and the 0.2. The 0 tells me to leave it alone. So I'm going to have an answer of 0.12. Okay. Now, the reason why we're doing this is pretty simple. This first answer that the calculator spits out, tenths, hundredths, thousandths, 10,000ths, it's implying that I have enough precision in my numbers that I can say that my equipment was safe to the 100,000ths. That's pretty good equipment, right? This answer over here implies that I've got enough precision to claim that my answer is good to the hundredths place. Now look at these numbers over here. Would you agree with 100,000ths or hundredths? These numbers here are all to the tenths place, right? So tenths place, tenths place, tenths place. Having an estimated digit, having some uncertainty to the hundredths place is all right. Having uncertainty all the way out to the 100,000ths doesn't seem reasonable with these measurements. So multiplication and division have one set of rules. Addition and subtraction have a completely different set of rules. Okay. With addition and subtraction, the answer can't have more digits to the right of the decimal than any of the original numbers. So there's no decimal point, then you have to wind up looking at place value. Basically, what I like to try and say is look at the last sig fig in each number and then determine where its place value is. You wind up rounding to the largest of the place values. So for instance, if I'm looking at this first math problem here, 3.7500 plus 0.22, looking at 3.7500, tenths, hundredths, thousandths, 3.7500 goes to the 10,000th place, and 0.22 only goes to the hundredths place. Okay. After I do the math, I'm not going to be able to say that I have any more precision than my least precise measurement. My least precise measurement was the one with less place values, which is going to be the 0.22. So I'm going to have to round to the hundredths place value when I'm done with this. So I don't think I need a calculator for this. I'm going to get 3.9900, right? I need to round to the hundredths place value to include the hundredths place value. So I'm going to keep that 9 because the 0 tells me to leave it alone. So I'm going to get an answer of 3.99 here. And of course, there should be units on that answer. 97, yes. Good thing I'm not recording this or anything, because, it'd be embarrassing to see that mistake happen twice. Sorry about that. I'm going to blame this cold that I still have. Blame the cold. Cold is making my brain not work well. It's making my voice not work well. Right, exactly. I didn't eat my breakfast this morning. Right, exactly. I got a Curious George tie on. I'm sorry, that's distracting me. Excuse me. So with this next measurements, I'm going to do this in the calculator so I don't get messed up. 1.85337 plus 22.6. The calculator is telling me, as long as I plugged it in right, 24.1 4, 5, 3, 3, 7. Yes? I'm getting a sure. Okay. All right. So when I'm looking at these numbers, the 8 is in the tenths, the 5 is in the hundredths, let's see, thousandths, 10 thousandths, 100 thousandths. So again, this is a fairly precise measurement going to the 100 thousandths. But 22.6 only is a measurement that's precise to the tenths place. When I'm all said and done with this calculation, I can't say that I have any more precision than the tenths place. So I'm going to have to put a bar above my tenths place. The 5 is going to tell me to round that 4 up. And it's going to be 24.5, along with whatever units this is supposed to be. Okay, this is kind of like saying, okay, I've taken a caliper, and I've taken this is a ruler that doesn't even have millimeters on it. It's just got centimeters. Can you take a ruler and then take a caliper and add those two measurements together and expect it to be precise? Probably not. Okay, so that's why we're winding up doing this rounding. That's where we're going to 20. And this final one here, 40 minus 10.72. Calculator's telling me 29.28. I've got out to the hundredths place value with 10.72, but what's my last sig fig in the number 40? Is it the 4 or is it the 0? Okay, I heard 0 and 4. It's the 4, right? There's no decimal here. So that means the 4 is my most precise digit, and the 2 is my most precise digit. So it's either the tens place or the hundredths place. I've got to use the tens place. So when I round this value, I'm rounding to the tens place. So that means the 9 is telling me that the 2 is going to round up. So I'm just going to have an answer of 30 with whatever units it tells me to do. The 9 tells me the 2 goes up. So I have to round this to a 3, right? And I have to maintain its place value. So I can't write down just 3. I have to put a 0 so the 3 is in the tens place value. Does that make sense? Okay. All right. We're doing multiple operations. Here's where we've got to actually use both sets of things. We do the please excuse my dear Aunt Sally. We round as we need to. Addition and subtraction has one set of rounding rules, and multiplication and division has another. So every time we finish up with an addition and subtraction, we'll wind up rounding. Every time we wind up doing a division, we'll wind up rounding. So for instance, with this first problem here, 14.775 minus 1.22, I should have been able to do that in my head. This gives me 13.555 times 1.17. Now, I'm not going to use 13.555 because I have to do my rounding on this first. Okay. So it looks like with 14.775, I've got the tenths, hundredths, thousandths place, thousandths there. And I've got the hundredths here. So that means I can only have a hundredths place in my answer. So that means this isn't going to be 13.55. It's going to be 13.56 because I'm rounding to the hundredths place. So 13.56 times 1.17 is the math that I wind up doing. 13.56 times 1.17. Calculator says 15.8652. Since this is multiplication, the number of sig figs is what matters for this rounding. It looks like there's 4 sig figs in the number 13.56, and there's 3 sig figs in the number 1.17. That means I'll be rounding to 3. So the 6 is going to round that 8 up, So my ultimate answer is going to be 15.9. A lot of work, right? Hmm, 13.56 times 1.17? Check your decimal. With the next problem here, we've got to do the what's inside of the parenthesis here, 14.67 minus 5.6689. Calculator spits out 9.0011. Can we use all those place values? No. It looks like hundredths place value is where I have to round to. So it looks like I'm going to have 9.00 minus, oh, that's a multiplication problem inside that parenthesis, so I have to do that first. 0.155 times 2.8895. That gives me, the calculator spits out 0.4478725. Just a giant number here. How many sig figs do I want in this one? 3. 1, 2, 3. So the 8 tells me to round the 7 up. So it's going to be 0.448. And then I have to do 9 minus 0.448. And the calculator tells me that the answer is 8.552. We have to apply sig fig rules. Are we concerned about the number of sig figs or the place value here? Place value, right? Because it's subtraction. So place value looks like I can choose hundredths or thousandths. Which one? All right. Sounds like you guys are understanding this at the very. You're getting the mechanics of it at the very least. 8.55. Okay. One more thing to talk about. Yes. I'm sorry. This is really easy. You can start the homework. Okay. Exact numbers. Okay. You guys know about one example of exact numbers, a counted value. Okay. Exact numbers always get an infinite number of sig figs as far as our rules are concerned. That way you're paying attention to the number of sig figs and measurements. Okay. Other things that don't limit the number of sig figs are going to be exact or defined measurements. Like we know that 3 feet are in a yard, right? Okay, so the number 3 feet and 1 yard in that particular case have an infinite number of sig figs apiece. 100 centimeters is 1 meter. That's a definition. So again, they're both going to have an infinite number of sig figs when we use them. That's going to come in important when we do unit conversions. 12 items is a dozen. Again, that's a defined value. So we're going to have a finite. We're going to have an infinite number of sig figs in both 12 items and 1 dozen. Could I come up with more of those? We can come up with lots of them. If they're paired together, then there's going to be an infinite number, right? If it's, then we'd assume it's a measurement.